Yeah, we're good. All right, everybody. Hello, let's get this show going after this crazy state of Unreal. That was insane, right? It's like, wow, I'm still, seeing it on the big screen for the first time. Amazing. So, yeah, today my talk is slightly less rehearsed, without surround sound and all that kind of stuff. And so we're going to want to go through a lot of cool stuff we have in development. I'm Arjan Brassi, I'm a technical director at Unreal Engine. We're going to talk about some future stuff as well, but I kind of wanted to tell a story of how we ended up where we are, right? And you know, the lessons we learn throughout some of these iterations of the engine and all that. You know, one thing as well, you know, nobody can predict the future, right? Especially not software development and all that. So this is our kind of, you know, some guidelines and some goals that we're going after. And some are more fleshed out than others. But, you know, I just wanted to kind of give that bit of a disclaimer. You know, I sometimes do these presentations and I try to talk about the engine. And the engine, there's a lot, right? It's kind of rough. You know, people have seen me trying to talk about the entire engine. And you have to go fast, and you can only skim the surface. So today I really want to talk about like these four things, right? Fidelity, right? Quality of the picture, of the sim, of the living world and all that. Open worlds, right? How do we efficiently make these things, right? How do we actually deliver on that? Animation, you know, both the authoring tool pipeline, but also the runtime. And then, you know, last but certainly not least, and you know, really importantly, dev efficiency. You know, let's make these games faster than we're doing right now. So yeah, start with fidelity, right? And that journey of where we came from, you know, really started with this like old tech demo back in 2020 already, where you know, right, really this goal of us was that, you know, looking at all this UE4 work where people were doing custom LODs, a lot of work to kind of bake the lighting, all that kind of stuff. But you know, like take more of this approach of like, well, it just works, right? Can we just you know, get a mesh up there, like insane fidelity, and just make it render without having to create lots and all that? Like have lighting that just works, right? That bounces, looks good, etc. Also, you know, without baking, without all that kind of stuff. You know, then from there on, obviously we went into this the run-up to actually delivering on UE5. So from a tech demo that was like half UE4 and half UE5, really going into 5 itself. And then, you know, like creating a photorealistic city like this for that Matrix and later city demo. And, you know, trying to get that fidelity really up, but also include cinema quality characters, have meta-humans there, have driving, you know, deformation, vehicle systems, physics, post-processing, all that kind of cool stuff, right? I think it still looks amazing. You know, but then, you know, often on our path for Epic, right, we want to get it in Fortnite, right? That's our path to get production ready. And you know, Fortnite basically means, well, it needs to run 60. You know, it needs to support you know, Fortnite isms. You know, such as, you know, we have trees that are moving. The world interacts when you swipe your pickaxe at it, and those kind of things. So we added like world precision offset to Nanite, right? We optimized Lumen to run at 60 on the Gen 9 consoles with this kind of fidelity. But also, right, we did some interesting stuff with taking PlayStation 4 content and baking in like a tessellation and displacement in a baking pipeline to kind of really up that fidelity of the geometry. You know, certainly a lot of lessons there. Like, okay, we don't want to have these baking pipelines, so you know, we'll come to that later. You know, and then we worked on this demo, and this is kind of the culmination of like the learnings we had from that city demo, where you know, that city demo had like a Houdini PCG type pipeline, and we're like, well, you want to make it inside the editor, like what you see, what you get, right? Really, you know, you don't want to touch individual objects anymore, and make that creation workflow much faster. You know, we had to do some tricks to get this even rendering. But you know, ultimately this was a tooly type workflow vision type demo where it was still running pretty slow, right? It wasn't runtime for your current gen consoles and all that. we also displayed a substrate for the first time, running on the car and such things, right? Really advanced material systems that we'll get through, and big simulation improvements with like car physics, tire deformation, all those kind of things. Then with 5.5 with megalights, right? That's kind of a next step in where we want to go with like lighting. People have called it like nanite for lights, right? It's like constant performance regardless of the number of lights on screen and all that, right? And outside of that, if you have your outside worlds with like your big sunlight and your big bakes, bounces and all that, right? This is more like an indoor solution, right? Where previously you could bake out all these lights into light maps and render the light maps, but we don't want to bake, right? We want to do these real-time lights. We want to have real-time effects on that. So early show of that, trying to get that into the engine. And then we did this, right? So if you look at all these previous steps, right, that's where we culminated into, right? So we have this level of fidelity running at 60, not Fortnite level of fidelity, right? We understand that this is more heavy, but also streaming this amount of fidelity through the world and all that, through the systems. We had to do a lot of work on optimization, and I love the fidelity for sure. But a lot of things we did here, right? Lumen quality and performance, the kind of getting the lumen at the feature set that we had for that Matrix demo, but now running at 60, right? So over that time, we built it like 2 times faster now, right? So that's huge. We have full hardware ray tracing, right, throughout the journey of us looking at ray tracing from these early demos towards now. We started to realize, also talking to some of the licensees, that maybe hardware ray tracing is actually ready for prime time, right? So we really started to embrace it, right? Megalights first. This is kind of the accumulation of that, where everything is going through that pipeline. The other thing here that we did is, we have this VSM shadow mapping, great, but people want to make open worlds with dynamic time of day and all that. So you can't really cache the shadows, right? If your sunlight is changing every frame, right, or your moon or whatever. So we spend a lot of time on optimizing the uncached performance of VSM, and also did tricks to make the VSM throttle based on the frame rate. So maybe the shadow quality goes down in certain areas to make sure the frame rate keeps up. All cool stuff with water sims and all that. And the interesting thing that we get from the teams is that actually rendering these large vistas is actually really efficient. Because lots of these pixels are just simple by the time we render them. They're small on screen, they're voxels or they're nanite LEDs, etc. So these scenes are actually performing really well. The market scene is heavier for sure. So interesting to think about that kind of maybe counterintuitive performance characteristics. For this scene with the village, right? Huge amount of parallelization, right? If you look at the frames and actually have a screenshot of an insights capture later, it doesn't look like Unreal, right? It's not game thread bound, right? It's going super wide. We're doing all this stuff across all the threads to kind of run this, and it's not just animation. It's like mover, state tree, motion matching. All those kind of things are all on threads, not depending on game thread, and can go super wide to kind of reach much higher counts of characters. This is amazing, right? Having nanite fallback to voxels for trees. The issue with tree geometry is like if you go very far in the distance, it just becomes like a random scatter of like noisy pixels. So voxel, if it's sub-pixel, is the best representation we found. So it actually generates these voxels automatically, right? Right now, if you select this expand foliage flag to kind of make the foliage bigger, that was kind of a tricky thing to fix. Leaves disappearing in the distance, it will generate these voxels automatically, and it will just display them when the clusters are small enough. So again, right, nanite way, no lots, no alpha textures, etc. Everything modeled out of the box. Super cool. You know, I think the other thing was kind of interesting is that you know, always throughout these cycles of consoles, you know, you have these first games coming out in the first few years of a console cycle. You're like, that's cool. It's kind of an uprest, maybe, you know, previous gen title with some new tricks and whatever. And I think now we're starting to hit like the second half of the console cycle, right? We can do this kind of stuff. Wow. You know, another thing, right, that we showed is like actually animating these trees, and you know, these trees, you know, are complex, right? In general, they have like 2 million polygons. You know, they can have like 400 bones, or these normal trees have like 400 bones. So this whole scene has like 100,000 bones being animated on the GPU, and is running in 0.1 millisecond. So super fast, and you can do full wind sims, right? We have demos where the wind is directional, goes from every direction. So you can start doing really interesting stuff with your foliage to actually, you know, because you're calculating it on a bone level, right? You're not calculating it on a vertex level, so it can be much faster to do complex, crazy stuff. You know, the other thing that we haven't talked about is we're actually even animating the voxels. So the voxels are skinned, you know. You know, it's based on screen size, so everything will animate until it's too small to see, and then we don't animate it anymore. So, you know, even at the background, you see stuff moving, and that's all voxels that are moving. Yeah, you know, and this technology is great, right? Nanite skeletal assemblies. So we composite these trees out of all these little elements. And, you know, what we call our hero tree, right? Because yeah, you have to show off, it's a tech demo after all. You know, 41 million triangles. You know, if you would store that as a monolithic mesh, I don't know, what would it be, like hundreds of megabytes or something? Yeah, ridiculous, you can never ship a game like that. So this way, you know, this tree, 12 parts, instantiated 2,000 times, and this hero tree has 850 bones, right? And it moves, and it's super small on disk. You know, the interesting thing is that you know, we need tools, right, to create this kind of geometry, and we don't have the tools yet, right? So that's kind of one of the reasons why it's also coming in slower, and it will take us until like 5.7 to truly deliver on this, because it's working, right? It's rendering, but how do you get the content altered? So you know, you can make importers from other things, and you have to make it in the right way. You know, our approach really is to kind of make our own kind of tooling to make trees. With our Quixel team, and kind of deliver that as a tool. Yeah, and then going forward, you know, a big thing for us has been performance, right? It's kind of the word you've been hearing a lot. I'm really happy about that word. I love 60 hertz. My first game was 60 hertz way back when. But we actually have an initiative at Epic, which you call performance or 60 hertz by default, right? So we want to make sure that everything out of the box is able to run at 60 hertz, right? So it's defaults, it's better templates, it's optimizing the code, it's shipping new best practices for folks, but also making a new sample, like not a demo, a sample that can actually ship to you that runs at 60 hertz on all the platforms and such. You know, more things, Nanite, right, for characters, right? You know, characters like metahumans have deformation, right? Have transparent things like eyes and such things. So that's on the dock for like future releases, probably next year. You know, getting megalites over the finish line, right? We hear people are having good success with megalites already. But, you know, we don't think it's ready for production yet, you know, which means, you know, don't ship on like 5.6 with megalites, because you're in for maybe some painful performance tuning and all that. But, you know, we hope to get there maybe by next year, and, you know, if you can update to that version, you can ship with megalites. A lot of improvements actually megalites, right? With better denoiser, better performance, directional light improvements in 5.6, you know, stuff that we haven't really talked about much. Substrate is also planning to go into production ready by the end of the year. That's our aim. You know, the goal for us really is to ship Fortnite using Substrate on all platforms. without any performance degradation, right? That's key, right? We can't have Fortnite suddenly run slower. So that's our big challenge right now. We're getting close, so that's kind of will bring it into production ready.
So that's exciting, which means that if you're working on games now and you have a couple of updates of Unreal to go still, start using Substrate, right? Start looking at it. I think it's the next fidelity of materials for sure. And then, last but not least, right, making these worlds feel more alive with simulation, right? Simulation, both Chaos and Niagara. Chaos, right? A lot of work going into Chaos, right? Not just performance optimization and tooling, right? Better debugging, a lot of work there.
But also, right, going forward, looking at memory usage and such things to kind of make it fit in memory better. Niagara, right? We have like two tracks, right? One is the stateless emitters, right? Really trying to get much more emitters on screen, right? Almost kind of analytically defining particles instead of like having the state stored, etc. So you can have, much more particles. But the other thing is like heterogeneous volumes, right? 3D textures that are animating, pre-calculated. Super awesome stuff. We're actually doing that in Fortnite right now, shipping it on consoles. So this is becoming real-time able. Also cool.
Going into creating large open worlds. It's kind of interesting, right? We've made our first open world demo in 2014. And it was kind of hacky, right? We did a lot of custom tricks to kind of load things and all that, right? Later we created like a thing called world composition. We did like a world origin rebasing to make these worlds work well. It still kind of looks cool, right? But we were quite aware that we had to improve that tooling to make it a lot better for people wanting to do those kind of things. So with the Valley of the Ancient demo, we really kind of started to deliver on like, okay, well, how do we make these worlds, right? How can we take these Quixel assets, composite the world, layer things on top of each other, kind of figure out like, yeah, maybe some of these workflows are not great yet. But yeah, we have world partition streaming in this demo. We have like data layers to turn on and off things, so that's a big step in kind of learning how to use those things. With open world or with City Sample, that was Houdini created, right? So we had fast point cloud importers, but it's kind of a weird workflow if you're working on like Houdini that doesn't look anywhere near your final result, and that lack of WYSIWYG is just obviously ripe for changing. A lot of other things happening here, like streaming solutions faster, mass entities, have a big world, things in there happening. So we built this new entity system to kind of simulate all that, and that was cool because we keep working on that going forward. Electric Dreams is that PCG system, right? This culmination of the PCG thing. This took a bunch of years to get to. And it's really interesting to see the kind of the building kind of smarter logic, right? Trees can fall over by even the PCG can do a raycast and figure out like, hey, well, how is the tree gonna fall and change and all that. But it's critical, making these kind of worlds. If you start talking about 20 kilometers, 100 kilometers, whatever, you cannot touch individual objects anymore in the large part of the world. So PCG has been a big thing that we also used for Lego Fortnite. And we haven't really talked about that much, but that was actually a kind of seminal thing for us, where we're actually running the open world toolchain, world partition, data layers, PCG, everything on all these platforms, right? This is like a 20 by 20 kilometer world, runs on mobile, Switch, and all that. It fits in memory, right? We had to do things like PCG generation of some of these objects, or placement of the objects. All the objects in the world are like mass entities, and the moment you start interacting with them, we hydrate them into full actor component type things. And that's a way to really compress down the memory and be able to make these super large worlds on a low end platform. Also stuff like calculating nav meshes and all that, right? You cannot store nav meshes on this kind of sized world even. So yeah, 5.6. Obviously, right, we already shown some of this stuff, you know, a huge amount of performance improvements. You know, we've been hacking away at trying to get streaming performance up and running. A lot of changes went in there, and yeah, we are like 90% faster with this thing called like fast geometry streaming plugin. You know, it kind of takes all the simple geometry out of your world and puts it in a different system that can stream asynchronously and really fast. You know, the other thing that we did there is improve the physics performance. So, you know, going through the world and adding things to the physics world, you know, can now go async and much faster. You know, other thing, not in this video, but the PCG system now runs on the GPU. And it's also kind of an interesting view because PCG can run every part of the pipeline, right? You can import things, you can bake, you can do it in the editor, you can bake it out, you can do it on load, but you can also do it at runtime on the CPU or runtime on the GPU. You know, it's kind of a way to almost compress things, right? If you have these kind of worlds that we're showing, you know, they have millions, you know, of objects, maybe even per cell, right? Just storing the positional data, the orientation, etc. for all these objects is just ridiculous. You know, you don't even want them in your simulation because you're not going to interact with them probably either. So, you know, some of these things are living exclusively at runtime or even exclusively on the GPU. So, you know, they're not even have a CPU representation. Going forward, right, with open world performance, it's really still a big thing, right? You know, doing simple things more efficiently out of the box without like baking and making crazy tools kind of optimize, right? That's a big thing. We're also looking at like better automatic streaming solutions. So, you know, maybe you can make dynamic grids that automatically partition the world based on where the detail is at and such things. You know, workflows, you know, we're aware, right, it's kind of part of the dev iteration, but, you know, editor boot up times, streaming in the editor, you know, going to Pi and back, going to platforms and back, right? There's a lot of work we're doing there, right? Really kind of helping the creation of this world with large teams, but also small teams to make them more efficient. And then, you know, another thing is actually shipping high quality biomes that are, you know, nanite set up from the start, you know, that have PCG rules built in and can be mixed and blended together easily. So this is some of our internal kind of fidelity tests with our biome type systems, and I think it's starting to get really cool looking. And you know, we hope to see people even ship biomes on the Fab marketplace and stuff, right? So that's just good content to build your world with. Then you know, higher character counts. Well, we showed in the demo already like a lot of work on the animation system, but also the mass entity systems. You know, to make like LLD type levels of gameplay maybe more easier to create, but also run at performance and hopefully give some more guidance in like how to do that hydration type step if you want to go to upfront fidelity. And then last but not least, prefabs. You know, Zach's kind of alluded to that. You know, we're kind of using UEFN as a test bed, a live test bed, because, you know, why not? To create this prefab, this scene graph system. And it's kind of the future, how we see this kind of stuff work, right, for UE. So, you know, UE6 will be kind of the combination of UEFN and UE5 type things, and scene graph will be like a prime way how to do these things. You know, there's big challenges there, right? The challenges are like, how do we get from an actor component model to this new kind of composition type entity model with scene graph? So, you know, there's work there, right? We aim to have UE5 to UE6 be a upgrade like UE4 to UE5, right? Not you know, complete rewrite and all that. So there's big challenges there, and we're testing it in the UEFN land right now. Yeah, and then the really exciting thing is we're working on a new terrain system. So this is a fully 3D polygon, not voxel, terrain system where you can composite 3D meshes together, blend them, deform them, etc., and it will be automatically baked out into optimized, partitioned, set up for world partition cells and all that. And working on making this even run on platforms that don't do nanite, so bake it out to meshes. So really early, right? Sneak peek. It will take some time. Hopefully by 5.7 we'll show a first thing in the actual engine and in a demo. So yeah, going on to animation. Animation is really big, right? You go from altering and making the rigs and retargeting runtime and all that to making cutscenes and sequences to actually running it at runtime. So we've been working on this full stack kind of animation tool set for a while now, and we've been using it internally, right? So all our animators are on this pipeline, right? We try not to use these external TCCs anymore, and people do not want to use them anymore, right? So we really got them into this flow, and they start to really like it. We've been innovating, I think, in this space a lot, by taking all the best practices and kind of putting it in there, and with control rig and all those things, like really making that better. And the no round trip thing is like you can animate in that nanite and lumen scene, right? You can animate it. If the thing is in the shadow, don't animate it, right? You look at the final pixels. It's really cool. 5.6 really, making everything better, right? The team went through everything. We have version 2s or improved versions of like tweening, motion trails, a lot of things in that pipeline. And also kind of animating with physics. You've seen the things of like, well, you can have dangly bits on stuff. Okay, cool. The other thing is you can now, if you move a arm or something, it does collision, right? So it knows how to react to like the internal mesh and skeleton and all that. So that helps, right? Making animation quickly. And then going forward, a lot of quality of life. Maybe kind of the most interesting thing we're working on is like, you see this stuff and you're like, well, there's a lot of effectors, a lot of gizmos, a lot of stuff going on. Like, can we make it more friendly to animate? Can we just animate directly on the mesh, right? So there's some cool stuff that they're doing on making these gizmos directly on the skin, and then and just drag the character around just on the mesh itself. So yeah, a lot of quality of life, making the work for animators lots nicer. Zip. Animation, the rigging and deformers, we've been spending a lot of time there, right? Just creation of skeletons, but also, deforming these meshes with like complex sims has been in the engine for a while now, right? And we've been shipping stuff in Fortnite for like 2 years, even on the PlayStation 4. This stuff is uses ML to make this model out of this sample animation set that can then be run in runtime super fast, like way faster than you can actually evaluate the animation even. So this is quite viable technology, right? You can use it in your games. You can do this kind of crazy stuff. It works on cloth, muscle, flesh. We have stuff like sliding fat over bones and how muscles interact with it. It's super complex. But very fast. So with 5.6 again, right, we have this procedural physics. We now can sculpt blend shapes directly in UE. So that's another kind of tool. Like how can we actually, do all this stuff right there? But also now, thinking about like, can we export this skeletal mesh animation and bake out as geometry into a external tool, right? So you can store it and open it in another tool and continue working there if you would so prefer. Going into future, the goal is to allow even sculpting per shot, right? And now you're hitting like movie quality type pipelines where every mesh has a different deformation even per shot, right? So we want to be able to do that, to really kind of fix up things if you need to on a per shot basis. And maybe last but not least, a lot of kind of interest and talk about doing better stylization. Photoreal is nice, but if everything starts looking photoreal, it's also maybe hard to separate all the different games. So stylization, there's cool stuff you can do, and we want to kind of make it easy to take like meta-human level stuff and then push it down on like stylized things and make it target back and forth. Retargeting, right? Really critical, right? You can retarget animation over different skeletons, different sized or different organized skeletons. It can run in editor, but it can also run in runtime, right? So for small people, you can actually retarget it there, right? And there's some really good stuff. You don't have to bake it out into animations in the editor. With 5.6, we have a bunch of new editor work with like a better operation stack, so you can see how the deformation or the retargeting kind of works in order, but also improvements to handle different sized and proportioned characters that are dealing with props. So by scaling the source motion, we can keep the props kind of aligned to differently scaled characters. Then going in the future, we have a bunch of ideas about spatially aware retargeting, like to prevent like self collisions and resolve contexts. This facial retargeting, like transfer from like one character to the other, transfer from a meta-human to a stylized character and such things. And then, thinking about like using ML to actually correct poses after the fact, right? So if you retarget it, do another pass on it to kind of fix the issues that might have popped up at runtime. Sequencer has been it's become our main kind of UE timeline tool, right? So anything that has a timeline in a real kind of use Sequencer. And Sequencer became really unwieldy and complex and rough to use. So over the past bunch of releases, we've been working on making Sequencer much more usable and making like different views of things to make it easier to handle. With 5.6, a bunch of cool experimental stuff, right? Like the seamless stitching kind of stuff to kind of go from gameplay into the cutscenes, where we actually use the motion matching data, like the pose and trajectory type stuff, to seamlessly blend into the animation, the cutscene animation. That's super cool. We have like relative scaling for audio. That means if you have localized dialogues with like different lengths of the samples, right, you can have the sequence adjust to that. A gameplay camera interaction system where we kind of have more procedural camera that can frame the scene, per what's actually on screen, right? If you have a different size character, if more characters on the screen, or you're in a different location, like have the character have the camera kind of respond to that. And then general like navigation and tooling to handle like complex cutscenes and make that more easy to navigate. Going in the future, Sequencer is really on the path to become like a kind of dynamic cutscene tool, right? Where we want to have cutscenes that are not completely baked out, but are responding to the world, but even can start to do branching and dialogue type support. So that's our trajectory, and we're slowly working towards that. So that's going to be really exciting. I think generally, keep working on like simplification, looking at these at these pipelines and making them easier to use, simplified timelines and such. And then, last but not least, maybe performance, right? Some of these sequences are becoming really big, right? There's a lot of data, a lot of UI on screen, and all that, making that easier and faster to do. Runtime, we've done a lot of stuff here, right? We took a couple of versions to get motion matching out of the door, but I think, with the game animation sample that we've released in like 5.4, really showcase great best practices, and I think, that animation is there for you to test the system with and see like, well, is this the system that I want to use for my characters? And then maybe, you can inject your own animation and build your own motion matching library for your game. You know, but a lot of stuff there as well to have to do with debugging, right? You know, now a system will determine which animation to pick, so you want to introspect why it's picked that animation, or maybe you have to inject another animation in that state, so it can actually pick that, or even the choosers have more control over the animations it picks based on what your gameplay wants, right? Is the character hurt? Is it you know, like those kind of things. So yeah, then with 5.6. This is actually an insights capture of the demo. You know, we go super wide with our new animation framework. This is basically 300 NPCs, 800 skeletal meshes animating over 52 milliseconds and 12 threads. So this does not look like Unreal of the past. So yeah, we know. We've been working on it. So really exciting. Also exciting that the game actually says wait for the game thread says wait for tasks. So the game thread's not doing anything. It's waiting. So exciting. You know, it's experimental, right? We're super excited about this, but very, very experimental. It will take some time for this to be ready. You know, the worst case is a couple of years. You know, we need to make all this tooling work. We need to learn from what we actually, or we have to, you know, take the learnings from this effort and build it back and say like, okay, well, what can we do better to make this pipeline more easy to use? So it's cool to see where we're going, but be careful. You know, maybe you can play around with it, make a little prototype, see if it works. You know, maybe it works better, but there's a lot of work to do in tooling and all that going forward. But yeah, this doesn't use animation blueprints anymore, right? This is just a completely new system, completely. Another kind of cool things in here is that you know, we have like you know, this multi-character interactions thing, and if you think about that, you know, it becomes more of a matrix of possibilities how characters need to navigate, right? If you have a cluster of people that you're interacting with and pushing against, or people animating between themselves, there's a lot of kind of islands that you have to resolve and all that. So there's a lot of scheduling that needs to happen to kind of simulate large crowds that have all kind of interesting interactions and such. So yeah, a lot of work in the next couple years, but we're fully on UAF with that entire gameplay animation team for the foreseeable future. And then yeah, you know, like we said already, you know, we go from web-based meta-human creator to, you know, a full inside the engine meta-human creator. So you know, we have. You know, it's cloud supported, but it still runs mostly in the editor, right? Much improved fidelity, right? We have a new database in the background that can do that. You know, the parametric body stuff is cool, where you actually blend between like all these different shapes of bodies and do the cloth resizing with Chaos Cloth on top of that seamlessly. So this is great to have inside the engine. Then, you know, maybe my favorite topic, developer efficiency and iteration speed. You know, as a grizzled old game developer, I think my first game was like 93, so it's been a while. You know, my iteration speed back in the day was like second, right? And now we have computers that are what, 100,000 million times faster, and the iteration speed is what, you know, if you're unlucky, it could take, you know, 30 minutes to go into pi, right? Or hours to go cook and all that. So, you know, we need to really kind of fix this stuff, right? It will help everybody. It will make sure that your team is more efficient. Maybe you can work with smaller teams, you know, but also, right, iterating faster means better chance to hit better quality, right? If you can iterate 10 times in a day or in an hour versus, you know, a few times in a day, then, you know what will deliver better quality. So we actually have a lot of systems in this place, and I kind of want to give you a bit of an overview of some of these systems because they all kind of play together. You know, you can use them individually, and that's fine. And some of you have like existing systems, and you plug in the right thing. But you know, if you're starting new or you're not super confident, you don't have a big build pipeline team, whatever, then you know, look at using all the things. right? So Horde is really kind of the key part that organizes all of it. So it's not just a CI/CD system, but it will show like build health, spit out analytics, ingest into Unreal Game Sync, manage distributed build machine farms, do remote execution on consoles and devices and such things, right? Really kind of the orchestrator of all the things. Then the other thing is called Zen. So Zen, right, started out as the word came from we just want things to be working without pain, right? It would just work, right? Be Zen. The overall goal there is really to not build or cook or sync anything that's already been done by somebody on the network. So a lot of systems in place there, right? We have the Zen loader where we optimized the loading, right? Loading into the map, starting into the editor, loading the things that you have to cook, all that, right? A lot of improvements to like unifying async and synchronous loaders and such. We've seen like 30-40% improvements in our load times with Zen loader. Zen server, a lot of components there as well. Maybe right. We started with like having DCCs on file shares. That worked well if you're all in the same office, and then COVID happened and people are at home and how do we sync these things? So we spent a lot of time like, well, can we make it into a cloud kind of DDC? Can we share these things? Can we replicate it over different sites and all that? But really kind of getting out of this file share work. But yeah, recently what's really cool, what we're doing is we're using Zen server as kind of a file system abstraction. Windows file system is terrible, right? You have virus scanners looking over it. Your IT has enabled stuff that you can't even turn off, right? It makes everything slow, like journaling, all that kind of stuff. So now what we do with Zen, we just read and write into Zen server constantly. So we don't hit the file system anymore, and we write it back lazily async to the file system. So that makes a lot of things really, really faster, right? And you have to kind of think about it. If you don't run Zen server yet, you should probably start doing that. On your build machines and on your clients, etc. Right? It's just this process that you run that the editor and our cookers will communicate with. So yeah, the Zen cooked output store is actually using that as well, right? So you're cooking things, you're maybe cooking it over multiple processes, etc. Don't store it into the file system directly, but store it into Zen, and then the next thing that needs it can read it out of memory again, right? So it's much faster. The cooked snapshots is basically being able to synchronize cooked stuff between machines, right? Between build machines and dev machines and all that. And kind of a delta transfer, which also makes that a lot faster. Then with 5.6, really happy to show that we now have Zen target platform streaming, and that's been a big thing, right? Unreal honestly was great at working in Pi, but working on device and on platform is painful, right? We know, all your designers are probably just in Pi all the time, and trying to drag them into an actual on device, on console pipeline was always hard. So we've been actually spending a lot of time there. So we now stream directly from the editor to the target platform over the network, right? Some of these dev kits have like super fast network connections. Mobile devices have USB 3.2 type support, so that's also really fast. So instead of like taking 26 minutes or something to kind of get it on the target platform, right? Cooking, packaging, copying over, booting, all that kind of stuff. It's now a lot faster. A minute. That's much nicer. It should be seconds, but hey, we're working on it, so we'll get there hopefully. The other thing, Unreal Build Accelerator. So if you're not using that, you should probably start looking into that as well. Really next level compilation speed. If you look at the graph of like what it's doing, it's really maxing out your whole computer. It's maxing out CPU, it's maxing out network, it's maxing out I/O, right? It cannot go faster than that anymore, right? If you have multiple computers, even in your own home office, just have UBA run on that, and you just go wide in your home office. That will help already. So Horde will help distribute UBA tasks over UBA helpers. We have this new thing where we actually can detect if computers are otherwise busy. So we do idle busy detection, so you can have other workstations just have help with the stuff. Really, really exciting. 5.6, a bunch of work like shader compilation. I work on Mac OS and Linux. The cache server is another kind of huge improvement. So that means anybody that has already compiled something like a PDB, OBJ, or whatever file, it's actually copied over the network using UDL compression and shared. Hearing some of our developers, in the past it was like, well, let's sync in the morning, build, and now I'll have a coffee or have breakfast, come back, hey, maybe it's ready compilation with compiling, and now you just like sync, build, done, right? It's like sometimes the whole. I've seen people compile the entirety of Fortnite and UE in like under a minute, right? A few, it's crazy. So. Really, really good stuff. Yeah, then on cooking. So, cooking has always been a problem. It always took a long time, right? Especially if you're on the final stretch, you want to make this demo run on a console, or you want to ship your game, right? At the end of the pipeline, it's very slow. We've introduced multi-process cooking, right? You can't use all the threads, but we go like 4 or 5 threads based on memory. It helps a lot already. It brings the time back. In Fortnite, brought it back from like 2.5 hours to like 1.5 hours or something. But really, right, our next goal is to hit incremental cooking. So now, actually, this works together with the Zen thing again, right? So Zen has a far better understanding of the dependencies of all the files in Unreal, right? And we can actually query that and figure out like, hey, well, what do we need to cook if you change a certain aspect of it, right? You can change a config file or a blueprint or code or whatever, and kind of only cook what's needed, right? And that's a huge thing. It's not ready yet. It's experimental, right? We're kind of running it in parallel to our iterative cooking type thing on Fortnite. So we can do like binary diffs on like the output and see if it actually generates the same output. But really, really doubling down on that. Yeah, then future stuff. A lot of things in the pipeline here. I think making editor startup, load, PI times, UEFN iteration times much faster is a big initiative. We have another kind of team working on that. Really big push. We have other things in the pipeline, very speculative, new serialization, a system like low level kind of loaders. Making incremental cooking by default for everybody out of the box, so you don't have to even select it anymore. Revision control, right? We have some new stuff in UEFN. Is that something we want to build as a thing? We'll talk about that later. And then, really minimal data transformation is like thinking about UEFN and say that metaverse type word, right? Well, you can't recook the metaverse, right? If you change a version, right? Why do we recook things in the first place? A JPEG from 20 years ago is still loading, so why could an asset in Unreal not be still loading by that time without having crazy versioning of everything? So there's work to do there, but we have ambitions in that space. So yeah, that was it. Still a lot to cover. We have a roadmap online, and it actually shows all the 5.6 stuff. Always good to take a peek. Leave comments, we read them, the team reads them. It's a good way, we try to kind of be more forward-facing, but this is there. So thank you so much. How are we on time? I have 2 minutes, so I can have like one question or something, or two. Only one question? No. Anybody? I'll be.